Hello everyone, hope you are doing well. So today we are going to do topic 24b, remaining parts of topic 24, that is mineral and organic constituents of soil. Mineral and organic constituents of soil. तो जो भी बची हुई थी टॉपिक 24 की जो बी ए में वो हम जाकर के बी में कंप्लीट कर लेंगे. वी विल कंप्लीट इन बी. So here first of all we will discuss what are clay minerals. Clay minerals. Clay minerals. So these are hydrated aluminosilicates. Hydrated aluminosilicates, secondary minerals with particles less than 0.002 mm in diameter. These are the active seat of physical and chemical properties. Active site. These are the active site or active seat, which what do you want to say, of physical and chemical properties. That is, the physical and chemical properties highly depend on clay minerals. So the chemical और physical properties होंगी किसी भी soil की उसकी clay minerals में depend करेंगी. I hope you all understand it. Now moving on to the types of clay minerals. The types of clay minerals. The first type is silicate clay minerals. Silicate clay minerals. It is divided into three types. Further divided into three types. First one is kaolinite group. Second group is Montmorillonite group, and third group is illite group. These are the three groups of silicate clay minerals. Here the ratio is 1:1. That is the ratio of silicate alumina. That is 1 sheet is of silica and 1 sheet of alumina. Here the ratio is 2:1. That is 2 layers or 2 sheets of silica and 1 sheet of alumina. And in illite also we have got 2:1. That is 2 of silica, 2 sheets of silica and 1 sheets of alumina. I hope you all understand it. Suppose this is sheeting 1 2 3. So here 2 sheets is silica and 1 sheet is alumina. But here what happens? Only 2 sheets, 1 is silica and 1 is alumina. So this is what ratios are. It is held by hydrogen bonding. It is strong. In kernite it is held by hydrogen bonding, which is a strong bond. In Montmorillonite it is held by weak van der Waals forces. Weak van der Waals forces. And in illite it is held tightly by K plus ion. It is held tightly by K plus ions. Here we have got no expansion. and CEC is less. What is CEC? Cation exchange capacity. Cation exchange capacity, it is less in monotromolite. We have got fine width of expansion, fine expansion, and the CEC is high. Low CEC, no expansion. High CEC, that is we have got expansion. Here we have got expansion, but less expansion than monotromolite. Less expansion than monotromolite. So in expansion capacity, monotromolite has the highest expansion. Then we have got elite, and in colonite we have got no expansion. So these were about silicate clay minerals. Hope you all understand it. Now moving on to second type, that is non-silicate clay minerals. B, that is non-silicate clay minerals. Here we have got two types. First is hydrous oxide of FeAl, Fe and Al, hydrous oxide iron and aluminium, Fe and Al. And second type is allophane, 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 allophane. It is present in red and yellow soils. Red and yellow soils carry negative charge. This is negative charge. These are non-sticky. Less plastic and less cohesive. Less plastic, that is they expand less, and less cohesive. This gives better physical condition to soil. Better physical condition to soil. This was about hydrous oxide of aluminium and iron. Now what is allophane? These are the amorphous mineral matter in soil. I hope you all have heard about crystalline and amorphous. So allophane is amorphous mineral matter in soil. It contains silica, plus we have got here leucosides. The cation exchange capacity of allophane is high, which means the expansion of allophane will be also more. Now moving on to the third category. I hope you all understand it. That is organic soil colloids. We have did silicate and non-silicate. Third one is organic soil colloids. That is humus. It is also amorphous. pH change is dependent. Change in it is dependent on pH change. It exhibit negative charge. It has mainly three compounds or three components. First one is humic acid, second one is humin, and third one is fulvic acid. It's get destroyed rapidly, gets destroyed rapidly. Here it's CEC, that is cation exchange capacity is high, and the humus micelle is composed of carbon, hydrogen and oxygen, CHO. As we all know, humus is derived from organic components. So this is about organic soil colloids. Hope you are understand it. So this was all about clay minerals and their types. Now moving on to next topic, which was once asked in previous years, that is chelate and boron carriers. Difference between chelate and boron carriers. Sometimes they will give you to explain chelate and boron carriers. So first of all, we should know what are chelates. So chelates are cyclic structure of metals and an organic component in which they are cyclic structure of metals. They are organic components in which two components are held together with varying degree of strength. When commonly used macronutrients became unavailable. When the macronutrients which are commonly used, they became unavailable into the soil, or unavailable for the plants, unavailable to plants. The chelated compounds supply nutrients to plant for longer time. So then what happens when the normally available become unavailable to plants? The chelated compounds supply nutrients to plants. So that is why chelated compounds or chelates are very important. Now moving on to the next point. They don't react with soil solution and remain in soil in much longer periods, for much longer periods. इसलिए आप जब देखेंगे इतने समय के लिए रहता है कि जब जो नॉर्मली अवेलेबल जो आमतौर पे प्लांट्स के लिए होता है वो खत्म हो जाता है, तो जो चिलेटेड मिनरल्स है या चिलेटेड कंपाउंड्स है उनके थ्रू प्लांट को न्यूट्रिशन मिलता है. दैट इज why they remain in much longer periods. That is why when the normally available compounds are destroyed or not been evilly used by plants, then the chelated compounds are highly used by plants. They are more stable in adverse condition. They remain very stable in adverse conditions. Example of chelates are EDTA, DPTA, CDTA. These are the some common chelates. So hope you all understand what chelates are. Now moving on to what are boron carriers. Many times difference can be asked, many times to explain both terms can be asked. Boron carriers. First of all, they are not chelates. They are used in transfer of micronutrient They are helps in sugar transport. They are not available in high pH. Not available in high pH. In high pH, boron carriers are not available. They are less thermostable. That in changing temperature they are not stable, and releases atom quickly in adverse condition, whereas chelates are mostly stable in adverse condition, but boron carriers release their atoms in adverse conditions. They form weaker complexes with lignosulfates. Example of boron carriers are borax, boric acid, solibor. Hope you all understand what boron carriers are. Keep making notes, it will be helpful. Now moving on to next topic. What is phytostabilization? Phytostabilization. It involves the reduction of mobility of heavy metals in soil. Reduction of mobility of heavy metals in soil. It refers to establishing a plant cover on surface of on the surface of contaminated soil, contaminated soils, which reduces their exposure to wind, water, and direct contact with humans or animals. Which reduces their exposure to wind, water, and direct contact with humans and animals. So due to plant cover, the heavy metals which are harmful are reduced, and their exposure is reduced. So as if they are not in direct contact with human or soil, or they are not exploited or highly transported by wind and water. So that is why we use plant cover as phytostabilization. It reduces mobility and therefore the risk of inorganic components without necessarily removing from the soil. It reduces the risk without removing harmful and inorganic contaminants. Risk of inorganic contaminants without removing them from soil. We do not remove it from soil. Now, what are the advantages of phytostabilization? Advantages of phytostabilization. It may combine treatment with ecosystem restoration. Combine treatment with ecosystem restoration. and this usually enhances soil fertility, as the contaminants are not highly mobile, they become less mobile. The remaining soil become highly fertile. It reduces the mobility of contaminants. And here the material handling is limited compared to other remedial technologies such as excavation. Here we have to only plant those trees with heavy roots or long roots that help us, but in excavation we have to remove the contaminated soil. So here we can say the costs are lower compared to other methods of removing heavy metals from soil or contaminants from soil. And the risk of transport of contaminants or harmful materials through air and water is highly reduced as the mobility is reduced. So this was all about phytostabilization. Hope you all understand it. So that is all for today. For any queries, do comment. If you like it, please press the like button. Do share and subscribe. Have a nice day. Thank you.